solution. Let's turn it backwards. Turn it around. And when we do that, we'll get, we're not really turning it backwards, we're just multiplying both sides by a -1. We get negative x squared minus 2x plus 3 is less than or equal to 0. Same thing. Now, I want to call this entire portion y. Y equals negative x squared minus 2x plus 3, and that's less than or equal to 0. So we are going to shade x values for which y equals negative x squared minus 2x plus 3 are less than or equal to 0, for which the y values of this graph right here, we're going to graph that, and then we're going to shade the x values for which that graph has y values less than or equal to 0. Okay, so let's make the graph of that. Now, of course, doing that graph, it involves some work that I'm not going to show. You can satisfy yourself. We will get the same graph that we got in video 65A. So it looks like this. Okay, so there's the graph of y equals negative x squared minus 2x plus 3. Now, the x values for which this graph has y partners that are less than or equal to 0, that's going to happen anywhere below this line, because this line is a line where y is equal to 0, and anything below it has y partners in the ordered pairs on the point that are less than 0. So it's everything from 1, x equal 1, all the way out to infinity, and it also occurs that we have y partners that are below the x-axis or less than 0 for everything that's less than -3. So I've shaded the x coordinates, the x values, on the x number line for which the y partners in the graph, I'm talking about these ordered pairs, all these ordered pairs, these are the x values that I shaded who have y partners on the graph that are less than or equal. And because it's or equal, it has an equal portion of the inequality, I was allowed to put boxy brackets and not round brackets. So that answers the question. The graph solves the original equation, inequality 2x squared plus 2x squared plus 2xy minus 3 is greater than or equal to 0 for these x values. Open it parenthesis from negative infinity to -3 with a boxy bracket, union together with boxy bracket 1 to infinity with a round bracket. Those are the x values that satisfy the inequality. They are the same as the x values that have y partners less or equal to 0 on the graph of y equals negative x squared minus 2x plus 3.